Hello everyone and welcome back to the YellowDog 3D tips blog. Today we're going to be looking at 3D camera stabilisation in Nuke. So here's the original footage on the left that we're going to be working with, and on the right is the end result. As you can see, it's really nice and stabilised. It is a little bit more cropped in. That's pretty much unavoidable when you're stabilising footage, it's just the nature of it. But this is a really nice way to stabilise your footage and you don't get any warping like you would if you were to use warp stabiliser. So the first thing I've done is drag two bits of footage into Nuke. One of them is our source footage that we're going to be using, and the other is just a still of a grid which I shot, which is going to help us get rid of the lens distortion. I went into this in lots of detail in the match moving 3D tips blog, so I'm not going to go into it right now. But all I've done here is just remove the distortion from the footage. I've shot the grid on the same lens so that I should be able to just pipe our original footage into this node, and it will get rid of all the distortion that the lens has created. So once we've undistorted the footage, we can bring in a camera tracker node, just connect the source to the lens distortion node, and the default settings should be good, so we can just click track. And I'll just let this run through. I'm going to pause the video now and come back once it's completed. So here we are, we've let it track all the points it needs to track. Now we can just click solve, which is going to create the camera coordinates. There we go, and that's just run through nicely. It doesn't look like there's going to be many problems with this shot. So we can then create our scene by selecting export scene and clicking create. So as you can see, it's made a nice little node layout for our 3D camera solve scene. So now I'm just going to set up the ground plane. And to do that, I'm just going to select some features which I know are going to be solid and there's not going to be much error on. So I know that these really contrasted areas, it's going to have had pretty much no trouble tracking. I'm just going to select some from either side, and this should give me the highest chance of setting up a accurate ground plane. So once I've done that, I can right click and go to ground plane, set to selected. And with these points still selected, I'm just going to create a card that just follows this axis. So if I look at this in the 3D view, there you can see the card and you can see a little point cloud which is created when we solve the camera. So I've just double clicked on the camera 1 node, which is going to display our camera in the 3D scene, and it does look like the camera move I did in real life, so I'm happy with that. I can then connect the card we just created into the scene, and obviously to get an image from our 3D data we're going to need a scanline render node. I can just connect the camera input to our solved camera, our object scene input to the scene, but obviously you won't see an image now, so we need to connect our background to our footage. So there we go, I'll just neaten up the pipes a bit. So as you can see, the card we've just created clearly isn't big enough. If we were going to project an image onto this, it would obviously be cut off where the edges of that card are. So I'm just going to double click the card and I'm going to go into its attributes, and I'm going to scale it up to just 5 by 5. This should give us enough space to be able to project an image onto it without seeing the edges of the card. So the next step is just to duplicate the camera, and this is because we're going to use one camera to project out an image and one camera to create a smooth camera path. So I'm just going to rename camera 1 to projection camera, and then I'm going to go into the attributes of camera 2, just open those up, and we're going to go to the end frame of our video and just delete all of the keyframes. I'm just going to close down some nodes. Just delete all of the keyframes out of the translate and the rotate, and this is because we're going to create our own custom camera path that's going to move with a smooth motion, and it's not going to have any of the wobbling or sort of unsteadiness of the original footage. So let's just have a look at what's happening in 3D. As you can see, we've got a projection camera which moves, and we've got camera 2 which just stays at the end of the camera path. So the next step is to create our projection setup. So I'm just going to go into the node graph and I'm going to drop in a project 3D node. So once we've got that, we can plug our camera input into the original projection camera. I'm just going to reorganize our node graph a little bit and put the card underneath the project 3D node just to make it easier to understand. And the image input of the card is going to be connected to the project 3D, and I'm going to plug the other pipe into our source footage. So what's happening here is the project 3D node is using the original projection camera to project on our source footage onto the card. So if I scrub through the timeline now and just show you what's happening, you can see that it's projecting out the footage onto the card, and the image that it's leaving on the card is perfectly stabilized. And this is going to allow us to create keyframes on our other camera that just move smoothly and don't have any of the wobbling of the original camera. So let's just set up our node graph to prepare for the new camera move. So I'm just going to unplug the projection camera from the scene, and I'm going to get the camera input from the scanline renderer and just attach that to our camera 2 node. So if we look at this now, you'll see it looks a bit messed up, and that's because we've got our background plugged into the scanline render, which we don't want. So if we look what's happening here, because we deleted all the keyframes from our camera 2, you'll see that the guitar is just completely stable. There is no camera move on it whatsoever. So this would be useful if you just wanted to remove the movement from a shot completely and just have a completely static camera. But that's not what we want. We want to just create a smooth camera and just stabilize the footage. So to do that, I'm just going to close down all the nodes. I'm going to open up our projection camera to see its attributes, and I'm going to open up the camera 2 attributes. So now I'm just going to go to the last frame and set a key on all of the transform attributes, so translate and rotate. So instead of setting up our keyframes manually, I'm going to use keyframes from our original tracked camera to put our camera in the right position. So I'm going to go to the first frame and just drag over the attributes from the translate and the rotate to the camera 2 node. So if you look what's happened now, we've got a smooth camera moving from the first position to the last position with a linear keyframe. And I'm going to do the same thing again about halfway through the timeline, just dragging those attributes over. And this is basically just creating simple keyframes with smooth and stable in between keyframes. So I'm going to do that about a quarter of a way through again, and then I'm going to do it about 3/4 of the way through. And this is just going to create a really smooth camera path, just using 5 keyframes, and it's basically just recreating the camera path just without any of the subtle movements that you would get if you had a keyframe on every frame. So I'll just play this back now, and as you can see, it's done a great job of creating a smooth camera path, but you'll still notice that you see some edges of the frame, and this can't really be helped because that's where the camera moved quite rapidly in the original footage. But we can fix that with just a bit of scaling at the end. I just turned off the original point cloud that was created from the camera solve just so we can see what's going on, and I've just put a transform node at the end of the node graph, and I'm just going to scale it by about 1.2. So you will lose a bit of the edges of your footage, but that can't really be helped. Anytime you stabilize footage, you are probably going to lose a bit of the edges. So if I just play this back now, you'll see we've got a really nice smooth camera path. If I play that alongside the original, I'll try and time them up as best I can. You'll see there is a great deal of stabilization happening. We're not getting any of those subtle rocking motions that were in the original footage. And although this is a really simple setup, it's actually a really powerful way to stabilize your footage. Like I said earlier, you're not getting any of the warping motions that you would usually get from warp stabilization. So I'll just play this from the 3D view, and you can see we've got a stabilized camera right alongside our projection camera. You can use this technique on all kinds of shots, although this is a very simple setup. We'll just use one card, but more complex shots might need a more complex system of cards to get the same effect. So thanks for watching again. I hope you've learnt something, and stay tuned for more monthly YellowDog 3D tips. Cheers.